It's fascinating to think about the idea that the Big Bang created the universe. That's what Einstein's theory suggests, and it's the foundation of modern cosmology as we know it. But the current scientific picture goes beyond that. Today, scientists believe that before the Big Bang actually occurred, there was a phase known as cosmic inflation. If we define the Big Bang as the hot, dense moment that sparked everything we see today, about 13.8 billion years ago, then this inflation phase happened just before that. So what exactly happened during that mysterious period? Believe it or not, what science currently tells us is that the universe underwent an exponentially fast expansion. Picture this. The universe may have started out smaller than a single atom, and within a fraction of a second, less than a millionths of a second, it expanded so rapidly that it became much larger than the observable universe, containing around 350 billion galaxies. This was an expansion so fast, so intense, that it's almost beyond comprehension. And when that expansion finally came to an end, all the energy that had powered it was released into space, heating it up and producing the particles of matter, the very building blocks of everything. Us, the stars, the planets, everything we see when we look up at the night sky. That is what we now identify as the Big Bang. Sounds like science fiction? It does, but this is standard cosmology today. Still, it leaves us with some huge questions. What triggered inflation? What caused it to stop? How long did it last? The truth is, we don't know yet. Here's one way to picture it. In the beginning, everything was concentrated in an incredibly small, dense point. Then suddenly, it expanded. From that moment, atoms, molecules, stars, and galaxies would eventually form. But what existed before that? Prior to the Big Bang, the universe was unimaginably cold and empty. But strangely, this empty space was saturated with a mysterious form of energy, causing the universe to double in size again and again, at least 80 times, in an instant. When inflation stopped, it didn't end all at once. It stopped in patches. And each patch that stopped formed a new universe. Some theories even suggest that this process of inflation never stopped, that it's still happening somewhere in the cosmos, continually giving birth to new universes. We may be just one among an infinite number of universes, constantly being created in a grand cosmic cycle. So what does that mean for us? Are we simply a tiny part of a much larger multiversal reality? If these other universes exist, then the fundamental constants of nature, like the speed of light, the strength of gravity, and the masses of particles, might vary from one universe to another. And then comes the big question: why is our universe so perfectly suited for life? Why do stars produce carbon and oxygen, the essential elements for life as we know it? Why does everything seem so precisely balanced for living beings to exist? One proposed answer is, because every possible universe exists. Out of infinite combinations of physical laws, it was inevitable that some universes, like ours, would support life. And obviously, we can only observe the one where life is possible. It's a mind-bending idea, yes. And to be clear, the concept of a multiverse remains speculative. But the concept of inflation itself, the idea of a period of rapid expansion before the Big Bang, is not. It's widely accepted and deeply researched in modern physics. Inflation tells us that before the Big Bang, the universe was cold and empty, filled only with space, and yet that space carried energy, enough to stretch the universe to enormous proportions and create the very initial conditions that would lead to everything that followed. Of course, there are other theories being explored too. Some propose that the very trigger for the Big Bang could have come from extra dimensions of space. Imagine that we're living on a sheet of paper. Some theories suggest that there may be other such sheets, other universes, floating nearby in a higher dimensional space. Then comes the question, what happens when two of these sheets collide? One of the most compelling theories suggests that collision is what caused the Big Bang. Imagine vast sheets of space, known as brains, floating in a higher dimensional cosmos. At some point, these brains collide. An immense impact that generates intense heat. That moment, that cosmic crash, could create something very similar to a Big Bang, right on the surface of that sheet of space and time. This is one of the bold theories attempting to explain what might have happened before the Big Bang. According to this idea, the collision of brains could have sparked not just one, but potentially multiple Big Bangs, leading to the fascinating concept of a multiverse. Sounds like science fiction? It does. These theories might seem far-fetched and disconnected from reality, but surprisingly, they are grounded in solid mathematics. And more importantly, they aren't purely theoretical. Some of them are supported by experimental data. But how can we actually test these ideas? The answer lies in the oldest light in the universe, known as the cosmic microwave background, or CMB for short. When we look up into the sky, we can detect light that was emitted around 380,000 years after the Big Bang. At that moment, the universe had cooled enough for atoms to form, making the universe transparent and allowing light to travel freely. That ancient light has been traveling across the cosmos ever since. Today, we have a European satellite called Planck, which has been capturing extraordinarily detailed images of this light. Think of it as a baby scan of the universe, a snapshot of what it looked like in its earliest days. In these pictures, scientists can observe minute variations in temperature and structure, tiny clues that tell us about the very birth of the universe. This baby photo of the cosmos is where theories like brain collisions and multiverses begin to find experimental support. To truly understand how the Big Bang emerged and what, if anything, came before it, scientists are working to unify the two great pillars of modern physics, Einstein's general relativity and quantum theory. Only by combining these two can we hope to answer the deepest questions. What is space? What is time? What is the universe? And where did it come from? Now consider this. The farthest objects we can observe in the universe are about 47 billion light-years away. That means the observable universe is roughly 94 billion light-years across. Strange, right? How can the observable universe be larger than the number of years light has had to travel since the Big Bang? The reason is that the universe has been expanding during that entire time. As space stretches, galaxies move farther away from us, making the actual distances larger than the time light took to reach us would suggest. Most scientists believe the universe extends far beyond what we can see, perhaps infinitely so. So, what lies beyond the observable universe? Probably more of the universe itself. Based on measurements of cosmic curvature and the structure of space, scientists are confident that the universe stretches well beyond our visible bubble. But how far? That's still a mystery. It could be infinite. With the help of modern physics and cutting-edge measurements, we've started to answer profound questions. What came before the Big Bang? How vast is our observable universe? And what lies beyond what we can see? But perhaps we're overlooking something, a question that naturally follows once we ask how everything began. How will the universe end?